Okay, I did my hair in between the last video and this one, so if you watch them back to back, you're like, wow, her hair improved tremendously. Yes, we have a wedding today in Iowa when I'm making this video. 5 o'clock wedding in Nevada, about a 40-some minute drive. So trying to get some work done before I get pretty, or as pretty as possible for a 50-some-year-old woman, before the wedding. So anyway, trying to squeeze these videos in quick. Okay, let's look at ones that you actually don't even need logs for. Okay, and these are rare because in real life things don't work out pretty very often. All right, so if you can get them to the same base, then you're like, well, okay, so if this is 2 and this is 2, then the exponents must be equal, right? I mean, if these guys are equal and they have the same base, then the exponents must be equal. So x plus 1 equals 4. Again, isolate an inverse. And remember, we really, as humans, only know how to solve 2 equations, right? Quadratics and linear. And so we always do inverses to get it into one of those 2 forms. So once I know these are equal, this is really linear. And you can check your answer. Sub it in, 2 to the 4th power 16. We're good. All right, same thing here. Now, you have to get the same base here. 4 squared is 16, not 8. So I'm going to make this into 2 squared. Be careful. And then I'm going to put that exponent out there. I'm going to turn this into 2 cubed and then put that exponent out there. Okay, so now they have the same base. So be careful. Remember, a power to a power you multiply. You have to use a distributive property here. So what is that? 4x minus 2. And same thing here, power to a power, you multiply 3x, what is that, plus 9. All right, and then now finally I have the same base, so I can set these guys equal. So the exponents must be the same. Isolate an inverse, right? So I'm going to bring this over as a negative 3x or minus 3x. So as x minus 2 equals 9. And then again, isolate an inverse. You want to isolate this guy. And again, this is just linear. X is 11. Okay, let's check our answer. 22 minus, that'd be 4 to the 21st power. And then sub it in over here. 11 plus that is 8 to the 14th power. All right, let me grab a calculator, just make sure I'm right here, because I could screw up. We all make mistakes. What is that? That's, woo, scientific notation, all right, for that guy. And 8 exponent, and again, caret key on this guy, 14. Yay, they're equal, right? They're balanced. Okay, let's look at this Euler's number problem, which again is kind of ugly looking. So let's see what we can do here. All right, on this side, it's already simplified. Let's look over here. This to a power would be x, you multiply, right? So that would be 2x times 1 over e to the 3. Okay, so in a sense, if you multiply straight across, right, I could just put e to the 3 down there. All right. So I just kind of combine those. All right. How do I, when you subtract, right, or when you divide, you subtract exponents, correct? So I'm going to get this guy equals e to the 2x minus 3. Okay. Now I finally have the same base. They're both base e. So if the bases are the same, the exponents must be the same. Okay, now notice, again, as humans, we know how to solve 2 equations, linear and quadratic. This guy's quadratic. So when you solve quadratic, the way you isolate an inverse is set them equals 0 and factor if you can, or quadratic formula if you can't. And again, it's always nice to have that leading coefficient positive. We don't, factoring with a negative is at the beginning is just really hard. So I'm going to bring it this way. All right, so 0 equals, this looks like it should factor, hopefully. 3 is prime, 3 and 1. I want the 3 to be positive because I want more positive negative. So let's check our answer. X squared, 3x, and a negative x. Yep, that gives me that, and negative 3. Boom. Set these equal 0. Now, notice how even when we do factoring, these become linear eventually, right? So that's that guy, x minus 1 equals 0. Again, isolate an inverse and use the inverse to isolate, just back and forth, x equals 1. All right, and again, I should be able to sub in my answers and check to make sure. On quadratics, I do expect 2 answers though. Okay, this is all great and dandy, except if I have 2 to the x equals 17, yeah, 17 I can't get to a base. So most things in real life are not pretty. All right, so how do we solve those equations? All right, so let me explain how I think about this, and then I will, do a lot of problems here. I think of these as single logs are inverses with single exponentials. Okay, so if I have a single log, I go to a single exponential. If I have a single exponential, I go to a single log. All right. If I have a double log, now again, it has to be condensed. So when I say that, I mean like a log, of blah, blah, blah equal to a log of, a single thing. So a double log would be a log on both sides, but it's a log of one thing equal to a log. And again, same base. If this is base 7, this has base 7. So if I have a double log, then what I would do is I would take them away from both sides, okay? And the reason that works is because in a sense, I would do the base to both sides. Like I would, in a sense, I'm doing double exponential and these would cancel, okay? So a double log, in a way, you're doing double exponential to both sides in a weird way, and these are just gonna cancel. So double log, I'm just gonna take them away. Okay, because again, in a sense, it's like I'm going to put 7 and raise that to the power 7 and raise it to the power, and then those cancel. So if I have a double log and I do a double exponential to both sides, those cancel and my exponents are equal. Okay, all right. And then vice versa, if I have double exponential, then I'm going to do a double log to both sides, which again is kind of like here I did an exponent to both sides. So then they canceled basically. So I did a double exponential in kind of in secret. So in a way, double exponential in secret because it cancels. So you don't really have to show it. All right. Here, if I have double exponential, so if I have like 2 to the x equals 3 to the x minus 2, okay, double, and again, single exponential, but there's 2 of them, one on each side. Then I'm going to do a double log to both sides, meaning I'm going to do natural log to both sides, and then the exponent can come down. This exponent, again, in parentheses, can come down, and you see how that turns into linear, okay? So the way I think of these is if you have a single log, go to single exponential. If single exponential, go to single log. If you have double log, do double exponentials, which basically just cancels. And so in a sense, you're taking away the logs, okay? And if you have double exponential, give a log to both sides, bring down and solve, okay? All right, I'm gonna write some equations. We're gonna go through the process. Just remember, single goes to single, double goes to double. All right, that's about it. All right, I'm gonna pause for a second, write some equations, and we can solve these. Okay, so remember, isolate and inverse. Okay, so this is, first of all, the function's not isolated. So let's do that. -3, I get 4 times 2x. And again, that 4 is separate. This is glued together. That's your function. You don't have 8 to the x power. This is 4 sets of this, okay? So you don't have 8 of anything. So don't be tempted to do bad math. Okay, isolate your function. Okay, so now we get rid of the 4 because the function is just 2 to the x equals 3. Now that's not pretty. Okay, what is it? Okay, if you can't do it in your mind, then you need a log, right? This is a single exponential. So what am I going to do? I am going to do a single log. Okay, so logs eat what? They eat the answer. They spit out the exponent and the base comes down here. Do you see how that becomes linear? And I do the change of base formula just because I think it's easier. So I do log of the big over log of the little. But if you have a calculator where you can just type it in other bases, then go for that if you want. And it doesn't matter if you do natural log or if you do normal log. So whichever one the log base 10. So log of the big over log of the little. What do I get? X is approximately 1.585. Yeah. Okay, so single exponential, single log, but you have to isolate first. Okay, let's look at this one. This is double exponential. Well, if it's double exponential, you're going to go to double log. Okay, so I'm going to do, and I like to do natural log. That's more common. Sorry if it glitched there. I had to edit a little bit because I didn't have enough space. So I did double log to both sides because remember double exponential, you need double logs. Okay, now bring this down in parentheses because of the exponent rule, right? And then bring this down with parentheses. What is it? 2x is at -8. Hopefully I wrote it down right. I think ln of what, 5? Okay, so now ln of 2 is a number. I mean, if you're like, if your final answer is a decimal, you could just convert those to those, but they're kind of ugly, right? I'm going to leave it ln of 2, and I'm going to distribute it. Okay, so the x is the coefficient ln of 2. ln times that is ln of 2. ln of 5, again, the 2x is the coefficient times the ln of 5 minus 8 is your coefficient, ln of 5. Okay. The only way to go from having, well, first of all, this is linear, which is great, but I need my x's together because I want to solve for x and my numbers to the other side. So I'm going to minus 2x ln of 5 to bring this guy over. So he's gone. And then I want this guy to come over here. So I'm going to subtract ln of 2 on both sides. What is it? Ln of 2 to get him over there. All right. So I have my x's together, which is good. Then over here, I have negative 8 ln of 5 minus ln of 2. Okay, the only way to go from having two x's to 1 is to factor it out. So do you see how these both have an x, but they're not like terms as far as the ln of 2 and the ln of 5 are not the same. If I converted them to decimals, you know, but they're not. So what I'm going to do is I'm going to factor that x out. So I'm going to pull the x out. And when I do that, what's left? Ln of 2 minus what? 2 ln of 5. So I'm just pulling the x out. So if I distribute it, you can see it, but I pulled it out. And then over here, I just rewrite. And then to do the inverse, I divide. Because remember, now we're solving a linear equation. So how do you solve for x when there's multiplication? You divide. So I'm going to divide both sides by ln of 2. And ln of 2 minus that. These cancel, x equals that answer. Now, it's possible that you might be on my math lab, they might have a different answer, and you're like, how did they get that? Or Newton. Do you see how these both have a negative? It's possible that they might multiply the top and the bottom by a negative, so they might make this a positive 8 ln of 5, positive ln of 2, and then so they multiply through by negative and a negative. This guy becomes what? Positive 2 ln of 5 minus negative. So they might multiply all this by a negative and all that by a negative, which equals a positive 1. So it could be a manipulation of that. So don't let that bother you. All right, I'm going to pause and write the next one with more space. Okay, before you do anything, isolate your function. So again, isolate it, doing inverses to isolate. That's what we always do. And our log function is just this part right there. So what do I get there? Oh boy, 18. Okay. And then divide by 3 to isolate the function. Log base x of 16 equals what? 6. Okay. I finally isolated my function. Okay. It is a what? It is a single log. So if you have a single log, you can go to a single exponential. Now remember, what do logs do? Log eats answers to spit out exponents, and the base is here. So if you hate log form, you're going to love exponential. Okay, so what's your base? Your base is what? X. Your exponent is 6 to the 16th power. Okay, now you're like, Julie, this is not linear. It's not quadratic. No, not yet. It is a 6th power. What is the inverse of a 6th power? It would be a 6th root. And so when I take the 6th root to both sides, I am going to get something that's linear, actually. Okay, now how do you do the 6th root on your calculator? Here I would go to math and I want that root. So I went to math to find that, and I would do 6th root of what? 16. Oh boy, not like that. I want delete. Let's get down in there. 6th root of 16. Hit enter. Okay, so I got approximately 1.587. Okay, if you can't find, that was under the math key. If you can't find that root, most of you would have X root somewhere on your calculator. The other thing you could do is roots are fractional powers. So if you can't find the root key, you could just take 16 raised to, and again, fraction should always be in parentheses because fractional roots are fractional exponents are roots. Okay, so I get that now. Again, that can't, you can't have a negative or anything on that. So you don't have to worry about, do I need positive and negative? You do not need to worry about that. Okay. All right. So that's that one. All right. I'm going to pause. We have one more. All right. So say you have a double log. Now this is not a double log. You have 3 of them. So you can't do that. So you condense. You use your exponent rules. When you're adding, you're really multiplying to condense. Now you have a double log. And so remember, you can cancel both sides because in a sense, what you're doing is exponential to both sides, and those would cancel. Okay. I mean, so it's kind of like double log, double exponential, double log. But usually we don't show that, right? Because we're just like, oh, I can just cancel those, right? And so if you have a double log, you can cancel, not a triple. You got to have double. Then see how that becomes linear? Isolate, inverse. There you go. You get the right answer. Okay. So again, single exponential, single log, single log, single exponential, double exponential, double log, double log, double exponential. I don't remember what I said. Oh, they're giving me bonus time. Okay, single to single, double to double. How's that? All right. Okay, good luck. I can do a tricky U substitution in another video.